Welcome to Turn Right Machine Works. My name is Keith. Today we have a sprocket assembly here, and this is what I call Chewy Chewy. Let's take a close look at this. The name of the game here is to reclaim the bore so we can press in 2 new bearings and reuse what's left of the sprocket assembly. Alright, we're going to put this in the 3 job because we lucked out and we have a divisible amount of sprocket teeth here that can be divided by 3, and we have 1 or 2 ways of locating this, and that's either come in between our teeth with the V of the jaw or right on the top of the OD. Now if we were to put it in there cradling the V, we have a little bit of run out and walk out because of the wear on the teeth, that the working surface of the teeth are worn away, so the accuracy is gone. So the top of this is nice and uniform, and we're going to set it up right on the top of the teeth themselves. Now you can see those 2 sprockets there and the center section there running nice and true. You saw how hammered on this sprocket is here. A little walk back and forth, that's minor for the speed that this turns and what it's actually turning. Now we have a nice true running sprocket. Now we're going to come in here and bore it, sleeve it, put it back in here and skim it to finish size. But at least we know that we can repeat within reason, locating it the way we have it right now. Okay, without knowing the complete history of this thing, I don't know if that's a sleeve that somebody already attempted in, or if it's this outside race expanded out and frozen in there. You know, this could be Chewy Chewy. It doesn't sound soft. Okay, we made it through the first pass here with no major incidents. We still have our insert on here. Sometimes this crunchy stuff really make you blow a $15, $20 insert here. Right in the center here, there's some valleys in there, and it looks like the shadow of raw material here of a diameter that it looked like that race is actually spun in there, and they fused themselves together, and that's why the thing didn't pop out when I got to the end of it. And we're really only 20 thousandths over that bearing size right now, so I have to take it that was the race that was swished out in there. We're going to continue boring this out now. I want at least 100 thousandths sleeve for a good fit for these bearings. Alright, we're checking our bore here with the snap gauges, and we're checking it front and back, and we're just checking, making sure we don't have any taper, things like that. We're right on the money there. We're going to see if we can improve our finish, and we are within 1,000 of being exactly 100 thousandths per side over. And we're going to take a light skim, just see if we can get a little better finish there. And then we're going to turn the slug that's going to be the new sleeve there. Just barely taking anything. It's just the tool pressure that's creating this cut. Okay, that little spring cut just barely did anything. About a half a thousand, just pretty stout material. But the finish is good, I like it. And we're uniform, both ends, same diameter. And we're just gonna kiss that off there, and then we're gonna get the other piece of material in here and start cutting. Okay, we're shooting for our finished length here. And it looks like we got about 90,000 coming off of there. This thing was real close, but we're just trying to turn a little slug here that we can register on. One side of this is like a half thousandth under. Alright, that looks good there. Get in here, crank us in some tool bit room. Okay. Okay, now we can turn our OD down to size to press into the sprocket. Change up tooling so we can get in between this bell center here. Okay, that'll go in fine. Check our travel. Always check your full motion. Make sure you're clearing everything. Okay, you can see the color of the chip when it's leaving the insert right here. It's a white metal, the same as the original base metal. As they're flying through the air, they're turning gold, and then when they hit and stop, they turn purple. That's an ultimate production chip right there. You're taking a good amount. You're not really pushing it, but you're not lagging either. Okay, this thing is still pretty hot, but we're checking. We're getting down close. We're within 25 thousandths. We're going to let this thing cool down. I'm going to get these warm chips out of the way too. They ain't going to cool it down. So we can get the right press fit on into that sprocket. Okay, we got her to cool down some, and she shrank 3 3¼ thousandths from the dimension that she was when we got done turning. That's how much size difference can be caused by temperature, and that wasn't even really heated up with the torch or anything else. That was it was tool bit heat. All right, take a couple more. Alright, we've just finished draw filing it, and I'm between 2 2.5 thousandths press fit I'm going to give this piece. I'm going to try to fit thousandths press, 1.5 on the bearings themselves. So let's get this pressed in. We sanded that side there, get rid of that raised up burrs. That off in the lathe there. We're just going to kiss it off for the same length here.
No, that's not a mistake. Live lobsters, all sizes, just 5.
Alright, every once in a while you want to reach into a bore, and a 1-inch indicator is hard to get in there and get a line on it. So we have this 90-degree attachment here, and this is an oldie but goodie here, and it slides right over the stem of your indicator, gives you the motion there, and we're just going to put it in here and check out what we got. About a thou and a half. These are also a little jiggly. This one here I haven't adjusted in a long time, so you can get a little bit. This is a rough finish in here, and it's been pressed into the bore, so we're going to call that done. Good. Let it go through. Looks like a good pass. Alright, this should be our finished cut here. We looked up online while this cut was going on, and we are right on tolerance here. They give you about 1,000th to play with, a half under, a half over the nominal. We're right there, maybe 2/10 over the middle. Alright, we're gonna chamfer that, give it a little quick emery polish. You'll see me use this a lot. I don't buy flapper wheels anymore. I just take a piece of 1/4-inch rod, take the hacksaw, put a cut down through it. This one here is probably about 6 years old. Then you just take your roll of emery, slide it right in there, rotate it around, instant flapper wheel. Alright, you thought this looked like Chewy Chewy. This is the shaft. The customer doesn't want to do anything with it. And I know it looks scary. You know, times are tight. May go on that way or the other way. I'm not sure. I'm not a tractor mechanic. There's probably some of you out there that know exactly where this goes. Catch you later. Get her done.